And welcome to PMI's Uncommon Sense podcast, tools to improve your work forever. I'm Susanna Clark, Managing Partner with PMI, the performance improvement consulting and training firm. Our Uncommon Sense podcast is a 15-minute conversation with our expert consultants. They talk a lot of common sense, although much of it is not common practice. And that's what this podcast is all about. We want you to be inspired to improve your business through learning more about the tools which can help you succeed and grow. It's great to have you back in the studio with me today, Dennis. Thank you for joining me.
Hi, Sus.
Today, you and I are going to talk about process capability or capability analysis.
Mm-hmm.
Let's just start with you giving an explanation for anyone who's not familiar with this. Mm-hmm. What is it?
So, a process capability study is simply speaking the comparison of the output of your process with the expectations of what the customer has and whether the output is meeting or matching the expectations that a customer set for that specific process.
Okay. And I don't know about you. I'm interested in what your experience is, Dennis, but my experience of this is what I would describe as either feast or famine. Mm-hmm. So I've got some clients who, wouldn't go to bed unless they'd done some capability analysis, and they report it regularly. They use it to also answer the question, why are we working on this problem? And I've got other clients who go nowhere near it at all. It's just not part of what the tools they use. And I just wondered about what your experience of this is.
I absolutely echo your observation. I've worked with some clients where indeed they use it as part of their normal everyday practice, and other clients where it's just a complete void. And sometimes I'm amazed by the clients where there's a void. For example, they are manufacturing clients or production companies where one ought to assume that this is just a normal part of the everyday way of working, but yet it isn't.
Now, recently, I know that you've been doing a lot of work on capability analysis. So I think what would be really useful would be for you to sort of talk us through as an example of that sort of work. What is it they're doing? Why is it important? What's it changing in how they're thinking in terms of working on process improvements?
So before I share with you an example from a recent experience, let me just talk through the method itself quite high level. So a capability analysis is the culmination of an incredible number of steps that one has to undertake before you actually come to that point. Number one, you need to understand your own process and how it's behaving today. That means you need to have data. Secondly, you need to have spoken to your customer, and your customers must have given you reasonable and useful specifications, be it an upper and lower spec or just one target. Then you need to, of course, do this comparison, but the comparison between the voice of the customer and the voice of the process needs to be such that the voice of the process ideally is actually behaving in a what we call stable, predictable way, i.e. there are no signals of assignable cause. Once you've done all those steps and you've hopefully eliminated the signals of assignable cause, then you can do a really detailed capability study. Now, fortunately, there's an alternative capability study where there's no prerequisite for stable process, and both are valid and useful.
Okay.
But basically, this can be a journey of months to go from knowing nothing to knowing something to actually knowing how capable your process is. So it should not be underestimated in terms of the difficulties and challenges on that journey. So very often, this could be a classic Greenbelt project, for example. One recent example that I have comes from an organization that does very large bits of assembly. And these bits of assembly, they can be, the size of a pint of milk for the smallest bit to literally something that's the size of a small house. And they all have to be assembled together to make this product work. So we talk about, heavy engineering. And whilst I was working with this client, I was there on the shop floor with them. We were discussing about specifications. Now, the specifications come from their engineering team. So I had a look at them. And of course, on these technical drawings, we see, this is a nominal, this is what should be maximum, and this should be the minimum for the features of this particular item that we were looking at. Then we took the item and we started to measure it. Now, for this measurement, of course, we had to go through a measurement systems analysis to make sure the tool was correct. Once we determined that the measurement device itself was capable of measuring this particular component, we proceeded with the measurements. We had multiple parts and we measured it. We realized that the process was stable and predictable, i.e. there were no unusual dimensions in the parts that we had. And every single part that we measured was actually within the spec.
Okay.
However, what we did, of course, was a limited sample of limited number of parts. Literally the ones that were available at that moment. So when we turn this into the control chart, of course, what you get is control limits, which are further away than the actual data in the sample. It's all a bit wider. Then we proceeded to do a capability analysis, and the capability analysis came back as highly incapable. And this became, for this client, a jaw-drop moment.
Right.
Where they realized that even though the parts that we sampled were in spec, the population at large was not in specification. And two key lessons came out of this. One, that in this particular organization, their incoming goods inspection was actually failing, i.e. it didn't exist. They trusted that what the supplier had given to them was capable of meeting the engineering drawing. But secondly, that the population wasn't capable of meeting the spec in a consistent manner.
Yeah.
And it was so far out that they have now created a project on this with the supplier to say, hey, we need to understand far better your processes to see what you're delivering to us, and therefore to make sure we have consistent quality.
So for me, who is not as rich in her data knowledge as you are, I find that really interesting, and particularly the piece about the sort of the difference between the sample size that you were looking at and the population. But it's interesting, intriguing, that difference that you see. So the risk is that one could get lulled into a false sense of security that the small sample that you're looking at. And so what I'm hearing you say is that it's the capability analysis that gives you a better picture.
Absolutely. Absolutely. Because in effect, the sample is a sample. But the question is the sample representative for the whole population, i.e. all the parts that they're getting from this customer? And in this particular case, we are talking about thousands per year of this particular item that we measured. So the fact that we measured 20, which is not a bad number, what does it tell us about the thousands that get delivered throughout the year in terms of their consistency, in terms of the tolerances and the specification?
And really, this becomes very important when you're also talking about high value goods, services, parts, because you can't sample. I remember working with one client, and they make firefighting equipment. Well, you can't test every tank, can you? So you need to sample, but you need better data in order to really be able to trust your sample.
Absolutely. And therefore that comes back to an intimate knowledge by your supply chain engineers, or the equivalent thereof, in the capabilities of your supply chain to deliver consistent quality. So you need to have a very strong relationship between the supplier and the customer. That's the only way you can make a proper capability study and, of course, an improvement plan.
And often I see it going hand in hand with a control chart, which you've mentioned about needing, a process that's stable and predictable. But am I right in saying you've got to master your control chart, master the stability of your process, and then move into capability? So don't stop just when you've got a what looks like a stable and predictable process.
Yes, you need to move on from that, absolutely, to that next step. The ultimate goal of any improvement activity is my process capable?
Yeah.
And not just today, but is it capable tomorrow? Is it capable in the long term? And to help with that, the statisticians have come up with different, parameters. Some of the classics are CP, which is just for, is it potentially capable? Then we have CPK, which is a very specific, refined one, which means your process needs to be stable and predictable, so no single assignable cause. And it gives you a really nice value then for that type of process. And then it's also called PPK, which means about, it doesn't quite matter if the process is not stable or predictable. It can have source of variation within it. It will still give you a useful answer within a production environment.
Okay. So the one thing I would say as well to anyone who's listening, who's thinking, good grief, this sounds far too statistically tricky for me. I just don't think I can do that. There are tools out there that help with this, aren't there? I know, we have our own data analysis tool that will produce you the capability analysis that you need. You've obviously got to have the data up front. So don't be put off by it, and do build it into any future process improvement work that you're doing.
I mean, absolutely, Suze. As a matter of fact, the graphical output from the capability analysis is a histogram or a bell curve with a couple of lines. And I think anybody without any understanding of the underlying maths, if they see the bell curve to be within the two lines, it's in spec. If the bell curve is too wide or it's shifted between these two lines, a bit like a goal and a penalty. But basically, anybody who can understand if it's within the two lines, it's okay. And if it's outside these two lines, it's not okay. As simple as that. Then you've got your message across to anybody. It then gives you some really simple values from these different formulas. Once you know how to interpret them, it's very easy then to share that message with anybody else.
Brilliant. Dennis, thank you. That was really helpful, and I really enjoyed your description of the example that you've been working on recently. Thank you for that.
My pleasure.
Thank you so much for joining us. You can find more episodes of our Uncommon Sense Tools to Improve Your Work Forever in our Knowledge Hub on our website, or, of course, your favourite podcast platform. And do subscribe so you never miss an episode. Don't forget to check out the show notes for this episode, where you'll find links to more content on this topic, which includes webinar recordings, toolbox guides, blogs, and infographics, and our training page. You can always drop us a line on team@pmi.co.uk and arrange a time to have a call to talk about how these tools can help you in your organisation. We'd really love to hear from you.